Hello everyone, welcome to second episode of Spark Internal Series. In this episode, we will see what happens behind the scene when you perform GroupBy operation on any dataset. Here I am in Visual Code where I have set up for running a Spark on Jupyter Notebook. If you don't have any Spark setup, you can watch first video of this series to set up Jupyter Notebook using Docker. Once you are on this code base, either you use compute playground or Spark Internals, both have the same setup for running a Spark on Jupyter Notebook. I just say Docker compose up. It will start all my containers. So it has started all the containers. I'll go to Docker desktop and just see this. Now here in Jupyter Lab, I will find a port called 8888. Just click on that. It is asking for token. So token is nothing but Jupyter itself. It has started this. So I'll just in this test notebook, we will get started. So here we will be discussing about one of the dataset called fire department dataset, which looks like something like this. Fire department calls for service 22 section. It has few columns here. We are not bothered about much about the data. It is around 900 MB. I just wanted to show you how this GroupBy work. So that with the file. So this is CSV file I have already downloaded and added to the container, one of the container. Okay. You can see this, that data is present in a directory called Apache Spark data. And just list that. So this is the mapping of your local system to Spark container. You can put that file under this folder called Spark data. So you see this file, I have copied it here. Okay, and this is mounted to nothing but this location. I'll just quickly create a Spark object on spark.zip folder. This folder since recent folder the in this in setup we have, if you see here, we have Spark master, Spark worker node history server, and Jupyter Notebook. So Spark master is hosted on 7070 port. I'll use that. You can access that using Spark // Spark -master, and the port is 7077. Close the bracket. Then we'll see dot config. Set up the warehouse path so that it does not split the files here and there. Spark dot equal dot warehouse dot PIR. You can give the path like any path. I'll just say opt/spark/spark warehouse. To close the bracket, and there's a say it or create. Now this should start. There is something wrong here. So okay, do capital letter Spark session. Okay, now it has started Spark object. If you want to see the Spark UI, simply go to the Docker container. Now Spark UI by default use 4040 port. If there is no application running on my system, this is the port you can do. You can see Spark is created. I'll just split this screen so that you see that parallelly. Okay. Now next step is we read the CSV file, the file which I have shown you here. Okay, and we start absorbing the Spark UI. Okay. This is a Spark date format. Format is CSV. And then I have in this file you have header as well. I'll just say let's see header will be true. And then I also want to insert the schema and just say dot option insert schema true, and then simply then load the file. Load path will be Apache Spark data class. As of now, I have only one file, so it's fine. But keep full path. Okay, I've just executed this. So now it has triggered a stage. Now you must be wondering why this kind of operation is usually a lazy operation. Why it is triggering a Spark job? Why it is written like this? It has done because we have added infra schema to true. Okay, so mostly if you are using CSV, most probably it will trigger a stage to understand about the file. Okay, that's why you see here it is saying load, and you see it's a file scan, and then finally you are getting the data. Okay, so we'll just simply I'll show you the data. Output left. Before that, maybe I will just show you the schema and okay, so all these columns we see these columns are uh, they are the columns physically. Okay, maybe we will use one of the column from here itself. Let's say let's use which column will be, let's say unit type. There is unit type. Okay, before we use, we just rename this raw df dot equals to raw df dot its column renamed. Since this is in capital letter, or maybe I will just rename everything. Okay, so I'll just say for calls for call in raw df dot columns. Then this will become renamed df equals to. I'm creating a variable so that when you run this again and again, you should not get any issue with column renamed all comma on maybe I think call is internal function. So let's use calls dot. I'll just convert everything to lower, and then I just replace space with underscore. Then say rename df dot print schema. Now everything has got renamed. Now we will use unit type here. Okay, any column you can use with low cardinality. I'll just say select unit type dot top duplicates. Now when I run this, will it create any stage? Okay, let's see. So far I have not triggered any action on this, so this will not create. This show is coming because we have run here show command earlier. Okay, we removed it. Okay, so here there is no action here. That's why it is not triggered. If I just run dot show on top of it, it should trigger a stage. So these are the distinct unit type. Okay. Now if you see, this is just so, and if you go to this one, you see this last one, there is the one which executed on this. So it has these many records. Okay, since we have not cached the data anywhere, whenever you trigger any action, it will again go back and read the data, and then it will execute everything. Okay, it has read that file from the source from local system. It has done the hash aggregate exchange, and then there is one interesting thing which we see here. When it has done exchange, I come to the topic also whereby it has exchange, why there was shuffle. It has triggered something, number of partitions went to 200. And then again something happened, something called AQ shuffle read, and where the number of partitions reduced to 1. Okay. Then again some hash aggregate, and then finally you are getting this result. Okay. Why this hash aggregate is there? Because with drop duplicates suffers the data. Okay. To understand what all data is available where, okay, it needs to shuffle the data and pull distinct data to different partitions. Now, whenever shuffle happens, okay, it uses Spark will internally use, there's a configuration called Spark SQL shuffle partitions. Okay, it will use that configuration to create given number of partitions. So let's see Spark. What is the value for that? Spark.conf.get. So the value is spark.equal dot shuffle dot partitions. See, this is 200. By default, the Spark SQL Server partition value is 200. So anytime if shuffle happens, whether it's a group by, whether it's a drop duplicates or join or anything, okay, which is a white transformation which triggers shuffle, it will always use this number to create whatever the number of value we have, that those will shuffles after the white transformation, such type of transformation. Okay. Now, because of this, there are chances that if you have, let's say, the data volume is too big, okay, or of skewed data, what will happen is Spark is only distributing the data just to 200 partitions. Okay, so these partitions can either get overloaded or get skewed. Okay, so now you know how to configure the best value for this Spark SQL Server partition based on your data. Okay, you need to increase or decrease this. You should attempt to keep the partition somewhere between 128 MB to 200 MB. Okay, now after this, it says AQ shuffle read and it's reduced the number of partitions to 1. Why that happened? So for that also there is a property called Spark SQL adaptive enabled. So if you know, there is a property called adaptive query execution. Okay, as part of that, it has, so there is a property where it will try to polish the smaller partition into single partition. Okay, so by default adaptive query partition is enabled. That's why it has reduced that number of partition from 200 to just 1. Okay, so what is that property? Spark SQL adaptive. If you see, this is true. Okay, now if I make this false, sorry, false. Now if I again execute this, so do I have again created a new command? Now see, it has created 200 partitions and there is no AQ now. Okay, here so far. Okay, moving forward. Now I will do group by. Okay, So similar thing will happen. So let's say agg dot underscore df equals to the data frame we have is renamed df dot group by. We'll do group by unit type dot agg. Let's say control star and loop. CB. Okay, I need to import count from whole Spark. That's it. Dot and source import. Okay, so again, this is a transformation. So there is no action happened here. Okay, there's no stage. Now once I run show command, it will trigger a new stage. Okay, I got the result. Now when go back, go to show string, and you see similar thing has happened. 200 partitions. Now if I just see how many partitions it has, dot rdd dot get partitions. So it is 200 partitions, right? Now you might be wondering, a unit type is just, I think this is around 12 values. So 12 values. Why this has again gone to 200? Okay, this is again the same reason, because what it does internally is it will see that it will calculate the hash value of your distinct unit type, do a modulus with, let's say, this number sparks equals several partition, and then decide where the data will go into which partition. Okay, now these values will have distinct hash values, but upon taking the modulus, it can go into any partition from 0 to 199. So if you just, let's say, divide, let's say the hash value of some of the number is 101. So if you take modulus with, let's say, 200, okay, or for simplicity, let's say 201. So this will be, it will go to the file number 1. Okay, similarly, let's say you have 225, okay, percentage. So modulus I'll take. So this will go to 25th file, 25th partition, sorry. Okay, similarly, it will distribute these values to any partition between 0 to 2 to 199. Okay. Now, the most of the partition will remain empty because this data is just 12. So maximum you can get 12 distinct values of modulus. Okay. So that is maximum. It can happen that one of the more than one key can go to one partition. Why? Let's say you have, so 201 is let's say hash value for airport. Okay. For medic, let's say you have 401. Okay. It is different from 201 because the value is different, so hash value will be different. But if I take the modulus will again come to 1. That means more than one key, here in this case airport and medic, can go to a single partition. Okay. What is this summary for that? That means you can have at maximum 12 partition. Okay. Equal to the, which is equal to the distinct values of unit type. Okay. So most of the partition will remain empty. Now again, if I, so as of now it is showing 200, but again if I enable this Spark equality enabled, then it will again become 1 because these partitions are small. So Spark will try to correlate these partitions. Okay. Now if I want to change this, let's say now we have not played with this number. It is 200 because of this. If I want to, so if I want to reduce it, then I can just simply set this value, whatever number I want. And let's say 10. Okay. Now if I again run this command, so, and then see this, then it become 10. Why do we need to control this number? Because if we have very small partitions, let's say even 200 partitions, those might be definitely very small. Okay, Spark will try to spit out 200 files in this case. Okay, which will again create a new issue called small file issue. Okay, to resolve that issue, we always try to reduce the number of partitions so that the partition size will increase. So now let's say with 200 you have partition size of hardly, let's say 5 MB, 10 MB or 20 MB. But if you reduce that to smaller number, Spark will try to compact, polish this partition to a smaller number of partitions, and that will increase the partition size, which will reduce the probability of getting a small files. Okay, so I hope this makes sense to you, and you are now familiar with Spark UI, how it is work. Thank you.